Right, morning everyone. Hope you've all managed to join us for our introduction to subsurface utility engineering. As I just mentioned, any questions throughout the presentation, please feel free to drop them down below. We will begin with a little introduction. So my name is Angus. I'm the SUE supervisor here at GeoScan. We are a BC-based firm and moving out east at the moment, and we specialize in subsurface utility engineering. Background on myself, I used to work in the UK, hence English accent, under the PAS 128 scheme. I moved over here a few years back, and now I work under ASCE 3802. I'm 22. So what we're going to talk about today. So we're going through an introduction to subsurface utility engineering, the benefits of SUE, effective use of SUE, the different quality levels that make up subsurface utility engineering. Then we'll touch on the registered utility locating technician scheme out here in BC, and we'll go through a few project examples. Again, after that, we'll field the questions. So please make sure you add them as we go. So what is SUE? So the SUE standards are dictated by the Association of Civil Engineers. The specialty practice of civil engineering as a branch. So when we're looking at these guides, I have the physical book here. If anyone that wants these, let us know. So traditionally, people look at utility locating, surveying, and mapping as kind of separate things. The SUE standards bring them all together under a branch that is overseen by engineering and the Association of Engineers. So there's some quality and professionalism added to an industry that's known for being somewhat skeptical, especially when you see people using witching sticks, for instance, things like that. So this is making sure it's professional and accountable. So what are the benefits of SUE? So the American Society of Civil Engineers, along with some other organizations, went through and did some studies. There's a number of studies, and we'll go through a couple of them from different years. And they basically dictate that for every dollar spent, for instance, this 1999 study, every dollar you spend upfront in a SUE project, you could save around $4.26. Now, we'll go through some other projects in a minute that have varying numbers, but the main takeaway here is you are doing an upfront investigation at the beginning of your project that does add to the planning phase, but it saves you down the line. And you're saving money when it comes to change orders and things once it gets to contractors, construction, in the areas where the costs really add up. We're talking about spending a smaller amount in the design and planning stage to save us down the line. Majority of the work out in BC at the moment for SUE, especially working under ASCE, is done during construction phase by general contractors. And these general contractors are knowingly doing them to prep in advance of change orders. So what we're trying to encourage through this webinar series is moving those studies into the owners or design phase before construction crews are mobilized. So this table here shows various projects, mainly based out in Ontario, and it goes through and shows the cost of relocation, cost of design. These are all projects that SUE studies were not completed on, and therefore they had to have a change order, have a change in approach, have some downtime. Many of these costs can't even be, they're added up because you're talking about the public having to take detours, the cost of businesses potentially closing because the road is closed for longer than it was expected. But on average, on the cost that you can easily quantify, you can see down at the bottom there in red is all the different return on investment. So that is taking all the savings that you would have had, or the money that you wouldn't have spent on a change order, minus it, and then comparing that to the cost of the SUE project. So in almost all cases, it is a saving, but it varies how much. And the change in how much is depending on density of the project, how well the planning phase was done anyway, and other factors, but you can always see there is a return on investment from doing a SUE project. The other one that people don't realize a lot is these drawings are then stamped, and they're professionally engineering stamped. So the engineer is taking on liability for this project, and they're taking it, breaking it down so that it's not all on the design engineer. And we'll go through that in a table in a minute. Another book that goes along with the ASCE standards is the Subsurface Utility Engineering for municipalities. Again, if you don't have these available, let us know. Contact us, and we can provide these for you. This book is meant to go alongside the standards, and it takes you through all the different ways to build these subsurface utility engineering into your projects. It goes through the benefits and how to tenderize the process and put it out into your designers if you're designing externally. So although we are hosting this presentation as GeoScan, the aim is education. So if for any reason you feel you want to join more organizations and have more impartial opinion, there's two organizations that we're part of here at GeoScan. UESI, which is Utility Engineering and Survey Institute. There's an East and West chapter. So East is Ontario, and then West is BC Alberta. So RAF, our BCLS, is actually on the board for that. And then the other one is NASTTBC, which is the National Association of Trenchless Technologies. I'm on the board for this one. We have regular events, and it's all about learning trenchless technologies and SUE and how they build up. And then there's regular conferences for them both. So effective use of SUE. A lot of times people ask when is the best time to perform SUE. Earlier the better, and I think this little caption from the specs is great. So we like to think of the utility investigation as a topo. So if you're going to send a land survey crew out to survey the curbs, the manholes, all the features that you would see on the road, gain property line information, that's the same time as you should be collecting utility information. So bringing your drawing up to quality level B standard. We'll go into the standards in a minute, but the earlier the better, but ideally at the same time you're commissioning your topographic study. So here's a table of when is the best time. So we the different quality levels there, D to A. If you're at the preliminary design phase, that's when you're doing your base maps. Quality level D, quality level C. A lot of these in BC are done in-house by engineering firms. And then quality level B is when they start contracting locators. But what they should really be doing is throughout the whole process, we believe, is contacting a utility subsurface engineering firm like ourselves, and then you can let them do the base maps, building from the base maps, letting you know when the quality level B studies should be completed. And then once your design is finalized or more finalized, you can begin the quality level A and start actually hydrovacing and daylighting. So the specs themselves. So you've heard me mention different quality levels. What do they actually mean? So quality level A is daylighting, or traditionally where you've been bringing the hydrovac out, you're exposing the line, you're finding the pipe. Quality level B is using geophysical methods. So GPR is often in the news, EM is the more traditional locating method, and along with any other geophysical tools that the SUE firm feels necessary for the area they're working to bring up the utility information. And then quality level C. So that's where you're taking underground record drawings and comparing it to a topographic study. For instance, finding manholes and then using the records to align those things together, or fire hydrants. And then quality level D. So that is pure record information. There's been no field work done for that, and it's just based on whatever records the owners can find. So you see, the way we like to think of it and explain it to most people is in risk. So once you're at quality level A, you've seen the pipe, you've surveyed the pipe, you've physically found it in the ground, That's your lowest risk. You know where that pipe is to a high degree of accuracy. And then as you move down query level B, your risk is a little bit more increased, but the information is still pretty accurate. And then as you're moving further and further down, you're losing that accuracy and gaining that risk. So it's all about what your project needs and how dense the area is, depending on what level you need to be at. If you're planning to, construct a new water main and you're planning to be 30 meters away from the water line and the record information for the area is very good and you've used it before, then maybe you only do a study to level C. But if you're, in most cases these days, wherever you're doing new utility work, adding utility into the ground or rehab, then I would say the minimum you're basically looking at is query level B. And then as soon as you decide the route, you're moving up to A and doing the traditional hydrovac. So how do these different quality levels interact? So what we do is we take all of the information, the different levels from D, C, B, and A, put it all together. We're using GeoScan judgment I put here, but it's professional engineering judgment to then decide how to best show that on a drawing. So we're obviously trying to, if there's been a daylighting program, we're obviously trying to use that information the most. In most cases, we're using the information that we've gathered on site ourselves from quality level B investigations using GPR and EM, find the lines, map the lines, and put them on there. If the study area is inaccessible for some reason, or there's areas that are of less importance, maybe we're using quality level C information. We're just opening the manholes. Maybe it's to do with traffic. Maybe you can't get in the roads for certain periods of time. And then we're really trying to avoid any quality level D information, and we're bringing everything up that we can. It's pretty hard to do that based on information and reconciling records. But depending on the area you're in and the records you have, our aim is to remove all the quality level D information that we can. So I talk about risk and how we're changing that risk by using a SUE engineering firm. So on the left is the diagram showing the total risk without SUE, and then on the right you can see that the different quality levels are changing the way that risk is distributed, and some of it being eliminated. So quality level D, so remember we're talking about just pure record information there. That's where we are almost at the same level as without SUE. Once you bring it up to C and you've done some SUE work on it, you've eliminated some risk and you've moved some over to the SUE engineer. And then once we get to B, the SUE engineer is taking a large proportion and the risk has been eliminated again. And then at A, the design engineer is taking on the least amount of risk. The SUE engineer is now taking on slightly more, but there's a large proportion of, a third or even half of the risk has been removed. So here's an example of the quality levels in action. So this is one of the universities near here. They were looking at installing electric vehicle charging in the building. You can see the building just there. So they're looking at installing electric vehicle charging. This is their quality level D study that they've done themselves. So they've basically gone to their facilities manager room, looked up the records, put them on one drawing together, and gone, where should we run our line? So as you can see from the record there, that only shows one water line. There is a transformer labeled. I'll see if I can point that out for you. There's a transformer labeled just here, but no information regarding where the lines came in and out of. So their plan was to basically run an electrical line parallel to the water, come into the building in the same place, and then feed out from there. However, once we mobilized the site, we were able to do a quality level B investigation and revealed this. So as you can see, that's a huge amount more infrastructure than was originally thought. So if they'd come just south of the water line, they'd have found a gas line. They'd have been trenching the whole way along with the gas line. They've gone just north, communications line and storm line. So what we've done by mapping these to quality level B standards, give them a much higher level of accuracy of the utility data and lowered the risk of unknowns finding these. They can then plan where they're going to move their service and connect to that building around this information. This has meant that they didn't have a construction crew mobilized and sitting there waiting for a redesign or having to think on their feet and decide where the line's going. The other one from this study is we actually found that there is, you see the orange line here, a communications line that had empty ducts in it, and it was low voltage. And so it meant that part of the projects as well was to install some extra communications, and it meant they could just use the empty ducts and run the communications there. So you can see how this return on investment is, it's so easy to find in most of these cases. This is a very simple example, but we'll go through some more. So as you can see from this one, we're looking at water mains. And this is basically dictating how we decide what the difference between quality level B, C, and D are. So the top left, these screenshots are taken directly from the ASCE 3822 specs, which is the most recent specs out. As you can see, the water main was found to quality level B, which is this solid blue here. It's then found a water valve, and the crew found an offshoot coming off that line. They also noted that they'd already surveyed the fire hydrant. However, for whatever means, traffic control, vehicles parked in the way, they couldn't access the portion in between. It could even be that the pipe material changed in between, and it didn't allow them to carry on with the investigation. So what they can then do in this case is they can take the quality level B up to it. The squiggly line, as we call it, shows at the end of the signal, the end of the quality level B, and then that's where it transitions to quality level C, and the line type changes because the confidence is pretty high there that it's going to be going to that fire hydrant. Now it could, do a 290 degrees in there or a few zigzags and things, but it's unlikely. But this is where using quality level B and quality level C information together can really finesse the project in the way that you can cut down the spending to exactly what's required for this project. Maybe the new service going in is actually on the other side of the water main, and there's no need to investigate it any further, and that would have required different traffic permits. So depending on the scope of the project and what you're working on, you can optimize what you're looking to achieve from these projects. The main change that we've noticed for our field crew working from 3802 to 3822 is that now, before it was possible to label lines as level C if you had found the manhole's topographic feature. Now the manhole has to be opened and investigated to prove that the lines are what the record shows. So you can see below this example, we have a quality level D main. The manhole's been opened and then inspected, found that the line is present, matches the records, found the next line, the next manhole down, the same thing, and then carried on with the scope of work was mainly between those two manholes. So it meant that the line in between could be upgraded from quality level D to quality level C. But again, with the 22, you can see the document, the snippet there from the top. It has to be opened and investigated and documented. And even now, the chambers, if they're not a standard chamber, then they have to be mapped and added to these drawings. So you can see some other examples where that's not the case. So when you've got quality level B water main here, quality level water main here, but the lines aren't matching up, you can't just start assuming those are zigzag. You can't assume the diagonal. We're using professional judgment here to say, this is quality level D. We would recommend further investigation if possible in this area. Maybe we should advance this area to quality level A if it's going to impact your project. Same when it comes to radiuses of pipes. It's pretty hard to be judging the radius, so we would recommend that you either conduct further geophysical investigation if you need to be in the area, or do a daylighting operation. So I'm going to talk you kind of through how this process works when it comes to manholes and quality levels. So for instance, here I've got a road. This is the two white lines, the edge of the road, the curb, and we have a storm line from a record drawing. So this is a quality level D storm line. Engineers decided, the design team have decided that they need some information on this line to conduct their new service infrastructure upgrade. So they send a crew out to do some land surveying. They find the storm manholes. Engineer then looks at this, goes, right, well, how do we interact with this? This is the surveyed storm manholes. It's likely that they're going to be on the chamber. So let's move this up to level C. So you can see the opened manholes confirm the lines in there. They've moved the quote level up to level C between the manholes. Either side of the manholes doesn't change. It's the same as the water main. Unless they go downstream or upstream from those manholes, they cannot upgrade the lines around them. So this is now quality level C. It's most cases the engineer or the infrastructure team that's designing now has decided that that's not a high enough quality level and the risk is still too high, so they want to do some further investigation and they want to bring it up to quality level B. Majority of work that we get contacted about is bringing lines up to quality level B because that's where the sweet spot is for a larger investigation, but it's still going to save you money. So the section was located with GPR, EM, duct, FlexiTracer, duct rod, whichever was most appropriate, and then the field crews choose that. So now we know we've got a quality level D on either side still because there's been no further investigation on either end of it. And we now have a quality level B line in the middle. So we have a pretty high level of accuracy and we've reduced our risk for that storm line in that section. Now, let's say the study goes further. Maybe we want a laydown area in this section up here. So we're now going to go out, find the next manhole, survey the manhole, open it up, make sure we've checked it. It looks the same as we were expecting with the record drawings. We can then advance that to quality level C, and that segment of line can increase. Again, the investigation area increases. We're now going to have to go into an intersection. Right, so how do we deal with this intersection? Well, we can get out there to survey the manhole, but we can't open it because of traffic. It's not going to be safe without a full shutdown. So we've managed to survey the manhole, which meant we could increase the line to D. Well, we can bring it up to D, and then we can use that information. So the other option here would be that they could get a smaller shutdown, quality level C information, or a larger shutdown and get quality level B information. But it all depends on the project. So if the survey boundary was this blue area that you can see here, and that was the area of interest, then after that, maybe it wasn't a concern. The other section of information that can be added to this. So we've got storm cleanouts on the north side of the road here. So it can be opened up, and if they can be found at both ends, we can have them as quality level C. If we just got the cleanout itself and it couldn't be investigated at both ends, then we've got quality level D information. If both these lines were opened up and found to be 3+ meters deep and the project itself was a shallow electrical service, that's enough information. There's no need to conduct further investigation. However, if this was going to be a new sewer or a tunneling project that was going to go underneath and relatively deep, this is where we'll be conducting quality level B studies and increasing the level of accuracy and lowering that risk again. And then after all that, if there's still areas that need higher assurances, or we want to make sure that the information provided is 100%, especially if it's on the crossing, then we're going to advance it to the standard, more traditional quality level A. We're going to hydrovac, we're going to find the bottom of the pipe, the top of the pipe, with the idea of the investigation, bringing it up to quality level B first, deciding the route, then planning around that, so you can minimize the amount of daylighting and hydrovacing required, especially when it comes to parallel lines along your trench. The question I get asked a lot on these webinars is about accuracy. So the standards define the survey accuracy to be, so if we're finding a quality level A, we're talking 6 centimeters horizontally and 3 centimeters vertically. So that's not the accuracy of the locating equipment, that is the accuracy of the survey. So when it comes to manholes, surface features in the quality level C area, and in the physical pipes on the quality level A. Quality level B investigation, 6 centimeters also, but that is purely on what the, you have to add in the tolerance of the equipment as well. But there is a set standard for the survey accuracies. Oh, if you're US, 0.2 feet. The other one that goes along with all the accuracies sort of conversation is the engineer might be fantastic. but it really comes down to who you have on site and what their level of skill is. So in BC, we're lucky because we are now regulated by ASCE BC, which is the Association of Technologists and Technicians, BCIT. It's generally unregulated. The sort of designator if you're out east, or locator if you're in the west. So using ROLT, or Registered Utility Locate Technicians, adds to your level of confidence when it comes to the on-site procedures, the on-site working. We all know that if it's not great going in, it's definitely not going to be great coming back out of the system. So to become a ROLT, it's 2 years of locating, and then you have to prove 20 complex projects, go in front of a board, present why you think you're good enough to be a ROLT accredited locator, and then they'll either deny or approve your application. So if you're working in a SUE project, it's really great if you can make sure that your crews on site are as high level as you're the engineer that you're contracting. We'll go through that and how to build that into a tender in a minute when we go through the project examples. Again, any questions on anything I spoke about so far, please drop them in the Q&A section. And then anything that comes down to locating equipment, we also have a different one if you want a different webinar coming up that you can watch regarding that. So project examples. So this is a project actually was for Metrovan. This was it was about 2.6 kilometers of new water main, and this is a 2.6 meter water main, so it's large, and there's not much moving around of that pipe. So GeoScan performed the investigation for Graham, the contractor. They were the GC on the project. We were contracted after the project had been awarded, and this was not done in the design phase. So we did the SUE investigation along the entire route, conducted the exercise, revealed that there was a design clash. So this blue box here is the air release chamber, and the red line, solid red here, is the alignment of the pipe. So although the gas line does not affect the alignment of the pipe, it did affect the air release chamber, which meant that there was going to have to be design changes. Now, Graham had already mobilized the site, and were basically doing this exercise so that they could get ready for the change orders that were to come. Had this study been done in the design phase, this would have been revealed, the gas line could have been moved, or there could have been some change to the design. The problem here is you've got Fortis gas line and a huge chamber that's going to require a lot of work to move in the design phase. So in the design stage, so you're going to have a crew that's sitting on site, unable to work, and then obviously billing per day for a mobilization and a standby charge. So what we would have suggested here is if this has been done in the design phase, this could have then removed the sort of the bureaucracy stage, and they could have contacted Fortis. The Fortis line could have been moved, or the design could have been changed prior to Graham being on site. Another big project we're currently working on is the Surrey Langley SkyTrain project. So this is under Hatch and TI. Both recognize the need for SUE on such a large scale project. And so we were the winning bid, and we arranged all the traffic permits, everything like that, because obviously there's no construction crew on site yet. And then we advanced all the utilities along the guideway to quality level B where possible, and C and D on the actual Fraser Highway right of way. This was to allow the pillar placements to be, tweaked by the bidders, because this is a design build project. And I think the main aim when it becomes a design build is you allow, it's the same as if you're giving them more geotechnical information, you're allowing your bidders to have the most possible information to then, well, as everyone calls it, sharpening the pencils of their bids. So they don't have to account for unknowns when they already have the information, they already have the investigation. And this project's been running for a few months now. We're hoping to still to finalize the product in the next few weeks for anyone that's working for TI on the webinar. The other example here, BC Ferries Langdale terminal. So we've seen a few examples there of roadways and why it works for infrastructure projects on roadways. This is a better example of like a terminal site. So for instance, a wastewater treatment plant, areas like that. So BC Ferries is looking to upgrade their infrastructure. So they were going to plan a huge array of upgrades, new waiting facilities, waiting rooms, bringing their environmental standards up, and just a large plethora of upgrades. So we went out, did the SUE investigation, did the entire terminal in approximately 2 weeks. Didn't affect any BC Ferries operations. The terminal ran as if it normally did. We then provided this information to BC Ferries, which then allowed them to optimize their design of the waiting rooms, etc., based on what the current infrastructure was. They could plan to move duct banks in advance of further work. The other one we did reveal or highlight for this project is we found that there was a few storm mains that weren't being properly, that were going straight into creeks, and then that was obviously then budget that had to be spent to make sure that their storm system was being, properly to code. But then, as you can see, we just finished actually one of the other terminals as well. If you need a reference, that's one of our favorite ones there from Mike. He's the senior project manager at BC Ferries. And I'll take you through how this kind of process came about. So BC Ferries put it out to tender, and then they specified what areas they wanted quality level D studies, what areas they wanted quality level C studies, and where they wanted quality level B investigation. So it allowed us to give them an accurate pricing, and it allowed us to focus our efforts and their budget in the most important areas that would yield the most results for them. There's no point focusing all your quality level B investigations on your budget in a parking lot that won't be changed for the next 30 years. Why not spend it on the area that's, the ferry terminal ramp, the areas that are most likely to be upgraded and can have the least amount of downtime. So we'd encourage from this process is you can be very specific with what you want, where you want it, and how that will fit into your project. It doesn't have to be blanket SUE investigation this whole area. We can work with you to specify areas and build up your project specs with you. The other one on this one is where they optimize and they use the registered utility locate technician as a set spec. So this was BC Ferries going out to the SUE companies in the area. So their minimum 3 years working with, back then it was 3802, we're now on 3822. But they not only did they specify the equipment and the engineer, their 2 years experience, but they also specified the technicians on site and the SUE technicians or SUE designators on site and what they had to have been experienced in. And then this is our commitments from GeoScan. So we have everything roll surveyed, quality process, following all the industry codes of practice and high quality engineering checks. So thank you very much for your time. And if anyone has any questions, Gareth will now field the questions through the Q&A portal. So throw them in there and I'll do my best to answer them.
Thanks, Angus. We've had a few questions come through over the course of the webinar. Yeah, if anyone has more, feel free to type them through the Q&A box there, and do our best to get to all of them. The first one came through from Brian. Do you offer 3D models of the underground?
We do. So in areas, particularly if you're a downtown intersection or a particularly busy area, we can take this data, and we're presenting mainly in a 2D format here. It all has elevations, etc., recorded, but we can then build out 3D models. You can have AR walkthroughs, whatever you would need for your project. We find that in BC, the people aren't quite used to 3D data yet, but it's coming. And then you can basically have a model. There's some examples on the specs and on our website. You can have a model of the above ground and underground fitted together. You can plan not only where the infrastructure is going, but you can plan where the crane's going to sit to install the infrastructure, and you can plan how this will all interact in a safe environment with what's existing in the ground. But yeah, if you want to check out our website, we have some 3D examples on there, or get in contact and we can send you some and we can talk you through the process.
Okay, next one here is from Sonia. Can you use third-party topographic information in a SUE project?
So third party, so for instance, if we were given a topographic survey and we went to the field to do the quality level B investigation, we tend to overlap and double check the topographic survey. We will also shoot the manholes, etc. In cases where they don't want us to do that, and they want us to bring it to level C, and they're providing the quality level C or the topographic study, what we can do is we will have to go out, field check the topographic study. We'll do that with our assistance of our BCLS and in-house land survey team. So basically, we will quality check the land survey topographic study. If it's good, we'll use it, and we'll use it throughout the project. It does benefit in some aspects of saving time on areas that have limited access, but the majority of the time, just the way land surveying works, they don't always pick up every surface feature that we can discover or dig out the manholes that we find there. So we tend to survey all the surface features ourselves.
This next one from Peter. Can you speak to the accuracy of the vertical of a scanned pipe? Deeper pipes are harder to find. Can you speak on that at all?
Yeah, so depending on what equipment and what depth, we generally say about 10 to 20% of the depth is the tolerance. So if we're 1 meter, we're talking about 0.9 to 1.1 is the range of the depth. We're going to, the 20 centimeters of range on that. If we're talking 2 meters, then we're obviously, 20 centimeters either side. So we're 1.8 to 2.2. But it depends on the equipment being used and also the site conditions. But the key aspect of all that is it should be communicated across. And so we are adding those notes, annotations, things like that into the drawings and also into the report that's issued. So we're saying the accuracies of the depths in this area are really good, but they're not as good in this area based on the conditions. And the tools that we used to find the pipes meant that this one was better than this. And I think the key there is if you are, as people say, threading the needle with your pipe, you're always going to have to go into quality level A. But if you're planning a 3-meter pipe, we can tell you that the street lights are at 0.5 meters, and you shouldn't need to be worrying about whether you're going to impact them if you're, directionally drilling, for instance.
Okay, and Kate asks, does GeoScan offer utilities digitization from paper as built drawings?
Yes, so we offer basically a service where if you could send us your entire utility records for a terminal or a private site, we could take all your utility records, conduct our field investigation at the same time, put them together. Or alternatively, we can do a quality level D study, in-house desktop study, and bring in your utility information, then highlight areas of conflicts or areas that don't fit based on the records. We can then recommend moving areas up to quality level C or quality level A or B, depending on what you're planning around them. If you've got new construction in an area, we could do that just for a small area, reconcile the records, then highlight areas that we think should be checked. So basically, we can work with you to be the most efficient with funds to then find the most amount of information for you.
Okay, this one's a little bit longer, so bear with me here on this, Angus. You've referenced US standards for subsurface utility engineering. Are these recognized in Canada? Do you foresee Engineers Canada or EGBC or other provincial engineering associations adopting these or developing their own?
Yeah, so we reference the American standards, which is the 3802 that I was referring to. So these are US civil engineering standards. There is some CSA S250 is the Canadian standards. They are not as widely used in the industry. They tend to overlap in a lot of areas, but at the moment, just with the ties Canada has to the US, we find that almost all companies that we work with are looking to follow the ASCE standards. And it is pretty widely accepted in Canada. I have yet to see one that's specified only the Canadian standards. They tend to either reference both or solely reference ASCE 3802. For now, I don't see a need to in the industry to develop a second set or try to merge the sets. The American standard is good and works well. In the UK, they have a different one. They have a PAS 128 system, and it's kind of a different, I would say, slightly more confusing way of doing it. I think the ASCE is pretty simple, standardized, and it allows interpretation where required and then professional judgment where needed, but it is pretty set in its how we go about our procedures.
Okay, last two questions here by the looks of it. So what's the difference between a survey company hiring a locator and SUE?
So we often see out here that a land survey or a small engineering firm will hire a locate company to come out, paint some marks on the ground, and then they'll survey them, put them together, and send it off. And it's kind of like a pseudo study. There's no follow through in that, where there's so many areas throughout that process that there could be errors. I mean, in BC alone, you only have to have one rainfall and the marks have all disappeared, and then you're left with a surveyor stood there kind of trying to interpret another contractor's marks on the ground to then put together. So we see that doing it as one company, overseen by one set of engineers, means that you have complete follow through from the first person going to site, opening the first manhole, or locating the first line. They'll either be the same person surveying or the same group of crew surveying straight away, picking up the marks, immediately translating them back. The drafting team will then work together with the field crew to design the drawings and make sure to the engineering standards. And then any discrepancies can be easily resolved by just going back to finalize some areas. But when you have these disconnects with subcontractors, or you actually tend to find that if you want to bring the drawings up to the same standards, you end up with a huge amount of back and forth in emails and questions. And oftentimes the land surveyors are not that knowledgeable about the subsurface. Understandably, that's not their area. So I would say that if you can make sure you contact a subsurface utility engineering firm, they will do the whole process in-house. They'll make sure it's all up to the same standards, and they can give you confidence in when they're putting coil level B, they know that that is the correct location that the locate team found the line on.
Okay, just a couple comments that came through, I think, referencing Kate's earlier question about US standards. Comments from Ophir. The new standards have been made universal for us and for US and Canada. ASCE 38 and 75 have Canadian representation on the committee. The CSA 250/20 is only an as-built standard.
There we go. So Ophir on the call there, he's actually one of the members of UESI, and a big help in advancing SUE, especially out on the west. So yeah, as you can see, the ASCE is what we're predominantly using.
Great. Okay. Just one last question here. It's probably a good one to end on. Could you share the presentation with us?
Yes, these presentations. So we have actually a series of webinars now. So Joe just recently did one again from GeoScan on utility locating 101 that goes into the equipment, what it can do, what it can't do, and what the crews on site are available. We also have one for our partner company, Concrete Scanning, and then this one will go alongside it, and they'll all be available on the GeoScan YouTube page for you to send round, trawl through, spend hours of your time watching. But yeah, they'll all be available on the GeoScan YouTube page. And if you have any specific questions, my email address is on the screen, or contact GeoScan direct. If you've got a project in mind, obviously we're happy to help and happy to take a look at it and see what we can do with introducing you to these SUE standards.
Cool. Well, yeah, that sounds like it for the questions. So we'll probably leave it there. We will circulate this presentation, as Angus mentioned. We can send it out via email, and then of course it will be on our YouTube page as well. But thanks a lot for your time there, Angus. I don't know if you have any final words.
Yeah, thank you very much, and have a good week, everyone.